A blessed and joyful morning, class. May I request Mr. Ikayan to lead us the opening prayer? In the name of the Father, the Son, the Holy Spirit. Amen. Once again, good morning, class. Before anything else, I want to make sure that you're fine today. So when I say clap once, you will stand up, and when I say clap twice, you will sit. Okay, clap once, clap twice, clap once, clap twice. Okay, thank you for the participation, class. Okay, before you take your seat, please pick up the pieces of paper and arrange your chairs properly. Let us recall our guidelines when we are having our lesson class. First, be always prepared for class. Second, raise your hand when you want to speak. Third, participate in class. Fourth, listen attentively when someone is reciting. Fifth, respect everyone in the class. Do I make myself clear, class? Miss Lumontod, may I know the number of the list of the absentees today? It is a pleasant to hear it that all of you are present today. You may now sit down, Miss Lumontod. Now, class, clap yourselves for having a perfect attendance. Before starting to our new lesson today, let's first start by doing an activity that will reveal your background knowledge on injective, surjective, and bijective functions. The title of our review activity is Two Truths and a Lie. I will be presenting different statements with different categories. You will figure out which statement is the lie among the three statements for that specific category and state your reason why it is a lie. First category is injective function. So statement number 1, an injective function is often called a one-to-one mapping. Statement number 2, an injective function is always on 2. Statement number 3, if every element in Y has the most one element at X, is said to be injective function. Okay, class, in the first category, which do you think is the lie there? Yes, Mr. Ordis. Which do you think is the lie there? That's correct, Mr. Ordis. Now let's proceed to the second category. So our second category is the surjective function. So the first statement is another term for surjective function is an onto function. Second statement, a surjective function is often called a one-to-many mapping. The third statement, it is said to be surjective function if every element in Y has at least one matching element in X. Okay, class, who can identify which is the lie in this category? Yes, Miss Sanrojo. Very good, Miss Jaira. Our third category is the bijective function. So the first statement, a bijective function is a function that is both injective and surjective. In statement 2, when we say bijective function, there is a perfect one-to-one correspondence between x and y. Statement 3, a bijective function can have multiple elements in the domain that map to the same element in the codomain. So which do you think is the lie there? Yes, Miss Ferolino, you are raising your hand. Which do you think is the lie there? That's right, Miss Ferolino. Thank you for sharing your ideas in the class, students. You've really learned from your previous lesson. Going on, let's have first an activity. Everyone, please read the direction. So thank you for reading. Any question, class? Okay, now let's start the activity. Thank you for your participation, class. Have you enjoyed our activity today? Okay, good. Let's have another activity, class. This activity entitled Classify the Set. The class will be grouped into 3 groups. Each group will identify different sets in the surroundings. This could be anything from the set of all books in your shelf or even the set of all stars in the sky. Once you've named these sets, your next task is to classify each one as either finite, infinite, countable, or uncountable. For example, the set of books on your shelf would be considered finite and countable because you can physically count each book. On the other hand, consider the set of all stars in the sky. This set is both infinite and uncountable because we simply cannot count every star in the universe. Give at least 3 to 5 examples. You only have 3 minutes to do it, class, and 2 minutes to present your output. Are the instructions clear, class? Okay, count 1 to 3 starting from the back. Now go to your group mates and form a circle. Do it quietly. If ever I cut you noisy, I will deduct your points. Now you can start. Time's up. It's time for the presentation of your output. Group 1 will present first, second the group 2, and lastly the group 3. Congratulations everyone! You did a great job in your activity. Clap your hands everyone. Since we are done with our activity, let us try to reflect these following questions. First question, how did you come up with your answers? Yes, Miss Fiorellino. Okay, that's good. Second question, how did you classify your answers in the given activity? Yes, Mr. Hussain? You're right. For the third question, what new insight can you share about the activity? Yes, Miss Sakurum? Very good. Clap your hands for yourselves. So for this lesson, these are the following objectives. So first, explain the concept of cardinality of sets. Second, solve problems related to cardinality of sets, countability, finite, infinite, and uncountable sets. And third, appreciate the importance of cardinality of sets, countability, finite, infinite, and uncountable sets. What do you mean by cardinality? Anyone from the class have an idea? Yes, Miss Sandrojo. Please stand up. That's right, Miss Sandrojo. Cardinality refers to the number that is obtained after counting something. Thus, the cardinality of a set is the number of elements in it. For example, the set 1, 2, 3, 4, 5 has cardinality 5, which is more than the cardinality of 1, 2, 3, which is 3. The cardinality of countable infinite set is equal to the cardinality of the set of natural numbers. Example, set A has an element of 1, 2, 3, 4, 5, and 6. That means that it has a cardinality of 6. A finite set is a set with a finite number of elements and is countable. An infinite set, on the other hand, has an infinite number of elements, and an infinite set may be countable or uncountable. Finite and infinite set doesn't mean that countable and uncountable. There is a difference. Can anyone give an example of countable and uncountable set? Okay, Mr. Manzul, give some examples of countable and uncountable set. Thank you, Mr. Manzul. You are right about your answer. So, the n or the natural number is example of countable, though they are infinite because it is possible to less them. On the other hand, the set of all real numbers is uncountable as we cannot less its elements and hence there can't be a bijection from R to N. Any question, class? Okay, none. So Miss Lumbuan will further explain the cardinality of set.
So here, cardinality of countable set, to be precise, a set A is called countable if one of the following conditions is satisfied. A is a finite set if there can be one-to-one correspondence from A is to n. For example, n close open parenthesis A is equals to n close and open parenthesis. This point is used to determine whether an infinite set is countable. If a set is countable and infinite, then it is called a countably infinite set. Some examples of such sets are n, z, q are rational numbers. So, the cardinality of finite countable set is the number of elements in the set. On the other hand, if it is an infinite countable set, then its cardinality is equal to cardinality of the set of the natural numbers. So, can anyone give me an example of cardinality of countable set? Yes, Miss Indong. Give an example of countable set. Write it on the board and explain why it is countable set. And here we are in cardinality of uncountable sets. Cardinality of uncountable sets. A set A is said to be uncountable or uncountably infinite if they are not countable. The set of real numbers is an example of uncountable sets. Similarly, intervals like bracket A and B, open parenthesis A and B bracket and bracket A and B, close parenthesis and open parenthesis of A and B, where A is less than of B, are also uncountable sets. Remember that finite set is never uncountable. The cardinality of uncountable infinite sets is either x sub 1 or greater than this. So here we are in cardinality of finite set. The cardinality of a set is nothing but the number of elements in it. For example, the set A is we have 2, 4, 6, 8 has 4 elements and its cardinality is 4. Thus, the cardinality of a finite set is natural number always. The cardinality of a set A is denoted by cardinality of A or n open parenthesis of A, card or open parenthesis of A or number of A. But the most common representations are cardinality of A and n is open parenthesis of A. Here are some examples of cardinality of finite set. If A is equal to A, B, C, D, E, then n open parenthesis of A or cardinality of A is equal to 5. If P is equal to Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and also Saturday, then n is open parenthesis of P or cardinality of P is equal to 7. So in this case, can you answer this following problem? Please write it in your paper. So most of you got the correct answer. Clap your hands of yourselves.
Proceed the cardinality of infinite set. When we say cardinality of infinite set, it is the cardinality of a countable infinite set by its definition mentioned above is the cardinality of n, and we use the letter from the Hebrew language called the Aleph now, which is denoted by this one. It is used to represent the smallest infinite number to denote by cardinality of n. If A is a countable infinite set, then its cardinality of A is equals to cardinality of n is equals to Aleph now. An uncountable set always has a cardinality that is greater than the Aleph null, and they have different representation. For example, the cardinality of the uncountable set, the set of real numbers, R, which is lower C in factor script. To summarize, the cardinality of any countable infinite set is Aleph null. The cardinality of uncountable set is greater than the Aleph null. Now that we know the meaning of the cardinality of a set, let us go through some of its important properties which help in understanding the concept in a better way. For the first property, we have if A and B are two disjoint sets, then the cardinality of A union B is equals to the cardinality of A plus the cardinality of B. Can someone solve this example? Let the set A is equals to H, A, B, B, Y, and for the set B is equal to L, O, V, E. Ms. Matugina, solve this problem in the board and explain your answer. Very good, Ms. Matugina. For the property number 2, we have for any two sets A and B, the cardinality of A union B is equal to the cardinality of A plus the cardinality of B minus the cardinality of A intersection B. This property is popularly known as the inclusion or exclusion principle. Yes, Mr. Ortiz, can you give me an example of this property? Very good, Mr. Ortiz. You truly understand this property. For the property number 3, we have for any three sets A, B, and C, the cardinality of A union B union C is equal to the cardinality of A plus the cardinality of B plus the cardinality of C minus the cardinality of A intersection B minus the cardinality of B intersection C minus the cardinality of C intersection A plus the cardinality of A intersection B intersection C. Yes, Ms. Saladaga, solve this problem in the board for the property number 3. Set A is equals to 1, 2, and for set B, 19, 20, 21, and for set C is 17, 19, 22, and 23. Excellent, Ms. Saladaga. You truly understand this property. And here are the other properties of a cardinality of a set. The relation of sets having the same cardinality is an equivalence relation. A set A is accountable if it is either finite or there is a bijection from A to N. A set is uncountable if it is not countable. The set's natural number, integers, and rationals are countable. The set real numbers is uncountable. Any subsets of a countable set is countable. Any superset of a uncountable set is uncountable. If A and B are countable, then the Cartesian product of A times B is also countable. Do you have any clarification or questions about the discussion? Now let's proceed to our next activity. The direction of this activity is the class will be divided into 4 groups. In each group, you need to solve the following problems and show your solution. Before you present your answer in front of the class, present your short yell first. Let's start counting at the back, then proceed to your group mates silently. You only have 10 minutes to answer. Did you understand, class? Now proceed to your group mates and start answering. Are you done, class? Now, group 1 will present first, then followed by group 2, and then followed by group 3. From the discussion that we have earlier, so yes, Mr. Manzul, what is cardinality of a set? Thank you, Mr. Manzul. Yes, Ms. Tamayo, what is the difference between finite and infinite set? Very good, Mr. Tamayo. How about Mr. Nice? How do you know if a set is countable or uncountable set? Very good, Mr. Nice. Yes, Miss Candones. How important the concept of cardinality of sets, finite, infinite, countable, and uncountable in a real-life application. Excellent class, you truly understand our discussions today. So the cardinality of a set is a measure of set size, meaning the element of a set. Finite set is a set with a finite number of elements and is countable. An infinite set, on the other hand, has an infinite number of elements, and an infinite set may be countable or uncountable. Always remember that finite and infinite set don't mean that countable and uncountable. On the other hand, if a set is countable and infinite, then it is called a countable finite infinite set. A set A is said to be uncountable or uncountably infinite if they are not countable. I guess, class, that we conclude our discussion for today. Thank you, class, for your active participation. And for this second activity, you may answer it at the back of your paper. And for your assignment, class, please do read and study in advance on our next topic, the arithmetic and ordering of cardinal numbers. Now, that's the end of our discussion, class. Thank you for your participation.